You ever wonder how an AI goes from just, spitting out words to actually reasoning its way through a problem? Well, today we're diving into a technique that does exactly that. It's called chain of thought prompting, and it's this really clever trick that teaches an AI to think in a way that just supercharges its problem-solving skills.
So here's what we're going to cover. We'll start by looking at where AI kind of messes up. Then we'll get into this show your work trick that really changed the game. We'll break down how it works, see its biggest victories, and then a really surprising twist, what's being called the curse of this technique. And finally, we'll wrap up with what all this means for the future of how AI thinks.
All right, first up, when AI gets it wrong. To really get why this thinking trick is such a big deal, we've got to look at the kinds of simple logic problems that these incredibly powerful models used to just completely bomb.
It really is a weird paradox, right? I mean, you've got these massive language models that can write poetry, they can write code, they can even whip up a sonnet like Shakespeare. And yet, for the longest time, if you gave them a simple word problem that you'd find on a grade school math test, they'd often just fall flat on their face. So what's going on?
Okay, check this out. This slide is a perfect example from one of the big Google AI papers that started it all. On the left, the question's super simple. Cafeteria has 23 apples, uses 20, buys 6 more. The AI comes back and says, with all the confidence in the world, the answer is 27, which is wrong. And the problem, as you can see on the right, is that the model isn't reasoning. It's just a prediction machine. It's guessing what word should come next. And to it, 27 kind of looks like a plausible number in that context, even if it makes no logical sense.
And this really gets to the heart of the issue. Without a step-by-step process to follow, the AI just gets lost. It can't break down a problem that has more than one step. It sees numbers like 23 and 6, maybe it just adds them together, and then it spits out a totally wrong answer as if it's a fact. And for a while, this was a huge roadblock. How could you trust an AI with complex tasks if it couldn't handle this?
But that brings us to the breakthrough. Section 2. The show your work trick. And honestly, this is such a great, simple way to think about a really, really powerful idea. Come on, we've all heard this a million times, right? Your math teacher, they didn't just want the final number. They wanted to see how you got there. They wanted you to show your work. Why? Because it proves you actually get the process, and it helps you spot your own mistakes. Well, it turns out that exact same idea is what unlocks reasoning in AI.
And that leads us to the official term for it, chain of thought prompting, or COT for short. All it is a technique where you don't just ask the AI for the answer. You get it to generate all the little steps in between, the reasoning that leads to the final conclusion. You're basically asking it to think out loud. And the craziest part, you don't have to retrain the model or do anything fancy. It's all about how you write the prompt.
And just look at the difference it makes. It's night and day. Instead of just jumping straight to that wrong answer, the chain of thought prompt makes the model spell it out. Okay, start with 23 apples. Subtract 20, that leaves 3. Then add 6 more, you get 9. Boom, the right answer. And it's all because we forced it to show its work.
So how does this actually work under the hood? Let's get into the mechanics of this step-by-step reasoning in Section 3.
So there are a few main ways you can actually do this. The easiest one is called zero-shot prompting. You literally just add a simple phrase like, think step by step to your prompt, and that's it. A more powerful way is few-shot prompting. That's what we saw with the apple problem. You give the AI a couple of examples of problems that are already solved with the reasoning spelled out. And then there's this really clever one called self-consistency. For this, you get the model to solve the same problem multiple times, each time coming up with a different reasoning path. Then you just look at all the answers and pick the one that shows up the most. It's kind of like getting a second opinion, and a third, and a fourth, which makes the final answer way more reliable.
And the benefits here are just huge. For one, it makes the AI break down big, messy problems into smaller, manageable chunks. 2, it gives us a peek inside the AI's thinking process. We can actually follow its logic, which is awesome for transparency. And if it does get something wrong, we can go back and see exactly where the reasoning went off the rails. But what's really wild is that this trick doesn't work on just any model. Researchers figured out the chain of thought is what they call an emergent ability. It just kind of appears once language models get ridiculously big. We're talking over 100 billion parameters.
Okay, so we've got the theory down. But where does this thing actually make a difference? Let's check out some of COT's real-world victories. The impact has been massive in a few key areas. For math problems, like we've seen, the success rate just goes through the roof. For common sense reasoning, basic questions about how the world works, it gives a really nice boost in accuracy.
And for writing code, it helps the AI produce way more logical and functional code because it's thinking through the steps before it starts typing.
And to put a real number on it, just look at this. On a tough math benchmark called GSM-8K, Google's massive Palm model hit an accuracy of 58.6% using chain of thought. Now, that might not sound perfect, but at the time, it completely crushed all the previous methods. It set a brand new state-of-the-art record. This was a huge leap, and it was all thanks to this one simple prompting trick.
Okay, so at this point, chain of thought seems like a total game changer, right? A magic bullet. But that is not the whole story. And this is where things get really interesting. Let's talk about the surprising curse of COT, when asking an AI to show its work can actually blow up in your face.
And this is the question a whole new wave of research started to ask. I mean, COT is amazing for complex, multi-step problems. But what about other kinds of tasks? Is it possible that forcing the AI to think out loud could actually be getting in the way?
And the answer, as you can see from this direct quote from a recent research paper, is a big yes. Researchers found that in certain situations, especially when the AI needs to spot a pattern from examples, chain of thought doesn't just not help. It actively makes the AI perform worse. They literally called this the curse of COT.
So what on earth is going on here? Well, the problem boils down to something they call contextual distance. See, the way these AIs learn in context is by looking at a few examples or demos and then figuring out the pattern. But when you stick a long, rambling chain of thought rationale right in the middle, it creates this huge gap. There's now a long distance in the text between the examples it's supposed to be learning from and the spot where it needs to give the final answer. And that gap basically messes with the AI's powerful built-in ability to match pattern.
And that's the complete opposite of what happens with direct answering. With that method, the examples are right next to the question. There's no noisy rationale getting in the way. The connection is immediate, and that lets the model's pattern matching engine do its thing without any interference. It turns out, for some tasks, that direct path is just way more effective.
So that brings us to our final section, the future of AI thinking. How do we make sense of these two totally opposite findings? When is chain of thought a blessing, and when is it a curse?
The answer seems to be in what researchers are calling an explicit-implicit duality. Basically, the AI has two different ways of thinking. On the one hand, you have explicit reasoning. That's the step-by-step logic that Coty writes out. But what the research is showing is that this process, it's often kind of flawed. The AI isn't great at figuring out the real rules just from a few examples. But then, on the other hand, you have its implicit reasoning. You can think of this as the AI's gut feeling. It's this incredibly powerful baked-in ability to just see and match patterns directly. This is what makes direct answering so effective. So the curse of Coty is that it forces the AI to use its weaker, explicit reasoning, and in doing so, it actually disrupts its much stronger implicit gut feeling reasoning.
So what's the big takeaway here? Chain of thought is an incredibly powerful tool, but it's not a silver bullet. It's not a one-size-fits-all solution. Its effectiveness really depends on the task. For complicated, multi-step stuff like arithmetic, it's brilliant. But for tasks that are all about recognizing patterns from examples you give it, it can actually be worse than just letting it answer directly. And this tells us something really important. The AI's thoughts that it writes out for us aren't always its best thoughts.
And that really leaves us with the big question for the whole field moving forward. As we build and work with these unbelievably complex systems, we have to find the right balance. When do we ask an AI to think out loud and show its work? And when is it better to just let it trust its powerful, and maybe a little mysterious, gut feeling? The answer to that is going to shape the next generation of artificial intelligence.